This conference will now be recorded.
Hey, thanks everyone for joining. And today is the second day for this Git tutorials. And as today, just to have a quick recap, we try to understand what is version controlling system and why is it needed for every one of us. And in that, the different types like centralized version controlling system and distributed version controlling system. So out of that, Git is one of the type of distributed version controlling system which is popular in the market. Okay, and then we just saw the basics about how do we install the Git client and the server where you can create a project. So that's what we just saw in the previous session. Okay, and in today's session, let's get more deeper into the workflow of Git, and we'll also try to see what are the different commands and options on how you will be able to store your code into the Git. So how do we use those Git client and concepts which is available in the Git? Before we get started, my name is Adam, and let's get into the topics. Okay, so there are some concepts that you also need to know. It's not just the commands that you would be using in the Git client. Okay. So in that way, what do we mean by a Git basic? So the first thing what we need to know is the workflow in Git. So how do you start and how do you stop? Okay. So that's what we call it as the Git workflow. So now when we say Git, we know that there are two parts of it. One is the server, the other one is the client. So now client is the place where you do all your changes. So that way, whenever you want to start your work, so let's say there is a project and there is a central or remote repository in the server like GitLab. So how do you get that files? So the very first step what you have to do is you have to do a clone. Okay. So when you do a clone, you will get a workspace in your machine. So with the help of the Git client. Okay. Now what happens inside your workspace? So you're basically, when I say clone, you're copying the remote repository to your local machine into this folder called as workspace. But ideally, in Git, inside your workspace, there are basically three areas, or your workspace in Git client is divided into three areas. Okay. So what are those three areas and why do we need? Okay. So that's also something important for us to know. So your workspace in Git client is divided into three areas. One is called as the working directory. Okay. And the second one is called as staging area, and then the third one is called as the repository. Okay. Now what are these? So primarily when you go inside your Git workspace, again whenever I say Git workspace, I'm referring to the client. Okay. So using your client, when you go inside the Git workspace, you see all the files which was available in your server like GitLab. Okay. So working directory is the area or the folder in which you will be actually seeing the files. Okay. So remember, so working directory is the place where you actually see your files, whatever the files. Okay. Now, repository is another area or a folder inside your workspace in which the metadata will be stored. Metadata means the version information, like how I say the transaction in your bank account, like that. Whatever the files that you modify and check in, there will be a metadata created, which is called as the version. So the information about all those metadata will be stored in this repository. So this is where if you see, when you do a clone, you're going to get a copy of the remote repository into your workspace, which is what we call it as local repository to this workspace. Okay. So now every workspace will have its own copy of repository. Okay. Now you see the files and modify the files in the working directory. And when you check in or do the commit, the transaction details or the metadata will be stored into the repository of your workspace. Okay. However, between this working directory and the repository, there is one more area called as staging area. Now, staging area is actually a virtual space. Virtual means it's not visible to you. But why do you need it then? So in Git, when you're modifying the file in the working directory, you are not going to directly check in, because in Git, when you try to do a check-in or commit, the metadata usually can be a collection of files. So in reality, you will not modify file by file. You will be actually modifying a collection of files. But that doesn't mean that you should not modify one file at a time. So whatever you are storing into the repository, you will be modifying multiple files or set of files, and you will be trying to check in that changes together. So this is how, when you modify some files, you will be doing it one by one. So how do I collectively put everything into the repository? Now, this is where, once you modify the files in the working directory, you need to go through a second step called as adding your files to the staging area. Okay, so this is like, you first see the file and modify the file in working directory, and then whatever files that you have modified, which needs to be stored into the repository, you add it to the staging area. So the purpose of adding to the staging area is, it will try to prepare what is needed for the metadata as a collection of file. So now if I have 10 files that I want to modify and store it together, then every time I modify the file, I can keep adding it separately or together. So that's where we take the file from the working directory, put into the staging area, in which it will be collectively creating the metadata. So we call it as a snapshot. Okay, so collect all the files and it will prepare something called as a snapshot. Snapshot means like a screenshot. At that time, what and all files have you added? Okay, so that's where, after you modify the files, you need to do git add, which will be putting the file into the staging area and prepare the snapshot for the check-in.
For each and every file modification, you need to add it to the
It's not mandatory. If you have individual files, you can do it. If not, you can modify all the files and in one go, you can say git add. But eventually, what I'm trying to tell you is, after you do a git add, you have some thought that there are few more files you want to modify. Then again, you can go ahead and modify, use the git add again and put the files into staging area. So whatever goes into the repository is not directly from working directory. It goes as a collection. So you choose what are the files that you have to put first. That needs to be added to the staging area. So using git add, you can add one file at a time or multiple files at a time. Now, in the staging area, you will get the snapshot of all the files that you want. And not only that, you can choose which file you want or which file you want to remove also from the staging area. So that's where staging area helps you to prepare that snapshot, which is ready for you to do the check-in. Okay. Now, once you have put everything into the staging area, and this is where you will be actually doing the check-in or commit. Okay. So now in Git client, when you say git commit, it is not going to take the files from the working directory. It is going to take the snapshot what you have stored into the staging area, and from here it will try to put into the repository. So this way, as a user, after you have done the clone, you go to the working directory, modify the files whatever you want and add it to the staging area. And when you feel what you want to check in, everything is there, then go ahead and do the commit. So that way, remember, commit takes the content what you have put into the staging area. Okay, so like this, you can continue doing all the changes and keep storing them as a metadata into the repository. Okay, now once you do a commit or a check-in, it creates that transaction or the metadata, or technically what we call it as the version, only in your local repository. Okay, so now you decide at what time you want to share it with others. So what do you mean by others? It is the remote repository. So yeah, users, but how do they refer the code? So everyone will be cloning from the remote repository. So now if there are 10 people in the project and you are one among them, whatever the files you have now modified and stored into the local repository, now it has to be shared by everyone, or you have to share to everyone. So how will they see your file? Is only when you put the code back into the remote repository. So this is where from your local repository, the metadata, whatever you have taken, how do you share it with others? Now, this is where we will be using another step called as git push. So, push represents pushing metadata from one repository to another repository. So usually it will be from your local repository to the remote repository from which you cloned your workspace. So this way, once you do a push to the remote repository, now whoever does a clone from this repository, everyone will be able to see your changes. So this is where practically first time you do the clone, so at that time whatever is available in the remote repository, you will get everything. So you continue doing your changes, add into staging area and commit it. Okay, and whenever you want, then you do a push in which what you are sharing the metadata from the local repository to the remote repository. Okay, so you keep doing this activity. However, now, like you, someone also will be doing changes from their local workspace on their machine, and they will be pushing the metadata into central repository. So now if you think like this, you are also pushing, someone else is also pushing. Now your workspace has only the commit ID, what, or it has only the metadata which was obtained when you did the clone. So when you did the clone, what was the content? Plus the new commits what you did in your workspace is what is available in your repository. However, if someone else has modified and pushed, where is that? It is on the remote repository. Now how do you get that metadata what someone else has pushed into your workspace? Because if I do a clone, a new workspace will be created and in that I can see everything. But within the same workspace where you are working, if you want to see the changes what someone has done on the remote repository and pushed, then you should follow a step called as git pull. Okay, so when do you do a pull? When you have a workspace in which you want to update what others have done and pushed into the remote repository. Okay, so the opposite of push. So push means what? From your local repository, you are pushing some metadata to the central or remote. Pull means from the remote repository, you are taking some latest metadata to your workspace, because you will not be doing git clone every now and then, because clone creates a new workspace. So you don't need too many workspace. So the workflow is the first time you create a workspace by doing a clone, modify everything, stage and commit. And whenever you want, you will be pushing that metadata from your local repository to remote repository. And then when your workspace is out of date and you want to sync with the latest content what is available in the remote repository, then you will use git pull. In fact, when you are trying to do git push also, git client will clearly tell you are trying to push some code, but in the remote repository, there is already some change available, so you cannot directly put your data first. So what you have to do in those cases, you need to do a git pull, update your files with what others have done, in which your data will be there on top of that. So you have to practically do a git pull very frequently and keep your files also up to date with what others have done. And then you will be doing a push. Okay, so this is the workflow: git clone, and then modify the file, git add, git commit, and git push. And whenever it is needed, you will be doing a git pull. Okay, so this is the basic workflow what you will be following. So let's try to do that now. Now, once again, for this, we need a remote repository, and we will do the clone and create the workspace. Now, yesterday, we just had some issues with one of my project, so that's where we couldn't do. So let's do it from scratch once again. So I'm going to use GitLab as my server. So let me create a repository, which is nothing but the project. So I'll create a blank project. Okay, I'll put it under the same one what we did yesterday, and we'll call the same thing my awesome project. Okay, and I'll make it as public so that I don't have to give the username and password every time. Let's go ahead and create this. Okay, so now this is our project, which is available under GitLab under a group called DevOps Batches, and the name of the project is my awesome project. Now, to do the clone, you would be using the HTTPS method. So this is where yesterday I had created, but I'm just replacing it now. So what is our remote repository? Under GitLab, DevOps Batches, my awesome project. Okay, so we have created, so we don't need this anymore. So let's start working on the Git client. So another thing that we saw yesterday is, as soon as you install your Git client, first thing you do is set these three basic configurations. Okay, fine. So now what is the workflow? Git clone, git add, git commit, and git push or pull, right? So in this, whenever you say git clone, you need to say git clone followed by the URL of the remote repo, and then where do you want to clone it as your local workspace, any folder name that you want. So here I'll put our new workspace or the new central repo or remote repo followed by a folder name. So I'll just call it as workspace 01. Now what happens if you do not give the folder name at the end? Git will try to clone this directly into the current folder where you are running. Okay, so that is where it's always a good practice that you give a name so that a new folder or workspace will be created. Okay, so for the sake of practice, what I have done on this laptop, I have created a separate folder called Git repo under the downloads. So you choose a folder separately in which you know where all your local workspace is available. So I'm going to use this folder for the rest of the session. Okay. So inside this, nothing is available. So what we will do now, let's go ahead and do the very first step of git clone, in which you are going to make a copy of the remote repository into our workspace. Okay. Okay. So now you see there is a folder created called workspace 01. Okay. Let me increase the font just in case. All right. So now this is a new workspace, or we created this workspace from a new repository. So what do you have inside the repository? we just have one file called as readme file. So you can check this. So this is where at this time, whatever is available in your remote repository is what you have cloned. Okay. Okay. So now this is the very first time. So that's where you have to create a file. Otherwise, there will be some existing files which you have to modify. Okay. So what we will do for starting our work, let's create some dummy files and work. Okay. Now I'll create a file called as test.java. Again, you don't have to worry about the file because Git doesn't care what file you are storing. The only thing it should be, it's a text file. So just for better understanding, let's assume I'm creating a Java file. Okay. Now let's open this Java file and let's put some content. Okay. So let's first, what I'll do, I'll put the date. Okay, I mean, you don't need to put all this in Java code, just for our understanding. Okay, so the first line what we have is December 28, 2022. Okay, let's just put only this one now. I'm just saving the file. So what do you have the content in this? One line. Okay, so we now created a file and we modified the file. So as per the workflow, the first thing you have to do is put into the staging area. Okay. Now for this, you will use the command called git add and the file name. If you have multiple files to add, then you can use directly a command called git add followed by dot. So dot represents current folder. So from this folder, whatever you have, take everything. Okay. So now I have only one file, right? I mean, what I have modified is one file. So here we will say git add dot. Okay. Again, ignore this warning. So as soon as you have done git add, what it would have done, it would have taken the content of what files you have modified and it would have stored into staging area, which is a virtual area. Okay. But it would have created a snapshot for that. Okay. So what's the next thing after that is to commit. And this is where when you do a commit, you need to use a command called git commit. And for every commit, you need to give a message. Okay. So this way, whatever is stored into the staging area, it will take that and it will do the commit. And now if you do git commit -m and let's say first check-in. Okay. So what it has done, it has stored the content into the repository. Okay. How do you know that it has stored? That's where for every check-in, it is going to create a metadata, or technically in Git, we call it as commit ID. Okay. Now to see that, you will use a command called git log. Okay. So log is like your bank transaction history. So far, whatever the transactions you have done in your local repository, it will show you. So come back here. Now pay attention. If I say git log, what is it showing? It's showing there are two commits or two metadata available. Why two? Because when we created the repository, central repository, by default, it adds a file called as readme. Okay, so for that readme, it has created one metadata. But other than that, what is it doing now? It has created a new metadata, and that one is what you just see now. Okay, so every time you check in, it will create a metadata. Okay, now let's get deeper into it a little later, but as of now, I'm just trying to show you. So now, whatever the changes you have done, where is it available? It is available only in your local repository. And you can go back and see this. So this is the central repository. Do you see that file? What is that file? Test.java. It's not there. And the same time, here, what is it doing? It is showing that the content is stored into the repository. Okay. So every time you check in, it will create a metadata. Okay. So now, whatever the changes you have done, where is it available? It is available only in your local repository. And you can go back and see this. So this is the central repository. Do you see that file? What is that file? Test.java. It's not there, and the same time In GitLab, the benefit is it gives you a wonderful UI. So now if I want to see the files, that is what you are seeing. So you can click on files and you can see in your repo what are the files available. So that is only one file. And if you want to see the transaction details, which is the commits, you can click on commit. So right now you can see there is only one commit. So that's where, do you see the difference? Anything that you do in your local repository inside the workspace is available only in that. So you need to choose when you are ready and you should be pushing the code to the remote repository. And this is where now if I want to push this, then we should use the command called git push. So what will push do? Take the metadata or take the version information from your local workspace to the central repository or remote repository. Okay, so now it has pushed. If I rerun it again, what is it saying? Why? Because your local repo and what is there in the remote repo both are same. So that's where it is saying nothing. So push blindly doesn't push the data. So push actually pushes only the metadata which is not available on the remote repo. Remember that. Okay. So now if I come back to the remote repo and now we are looking at commit IDs. So if I refresh this, do you see two commits? So this is the commit that we did. And same way, if I go to files, I should be able to see the file. So now if someone does a clone, what will happen? They will also get the test.java or they will also get those two transactions together. Okay, so let's do it once again and I'll show you. So you have your workspace. So what you're going to do, you're going to modify or create any file. Now I don't want to create, so I'll take this existing file, okay, and in this now we'll just try to take module, okay, is DVCS. So what is DVCS? Distributed Version Controlling System. Okay. So I've just added second line. So now what should I do? Once I modify, I should be doing a git add dot git commit and some message. So I'll say second check-in. And whenever you do this, you will get a new commit ID or the reference, which is called as metadata. Okay. And now where is it available? Only in your local workspace. And to share it with others in the remote repo, you will do a git push. Okay, so it's pushed. And now go back to the remote repo and if you refresh, it's the same file, but click on the file. You should see you have two lines. Hope it's visible now. Okay, so same way, if I go to commit ID, I should see three commit IDs. Got it? Okay. So this is from one workspace. Now, just like how another person can work, so what we will do, let me open another git bash command prompt from the same machine. Assume now another user from another laptop or machine, they are working. So what they will do, they will open a git bash command prompt or a command prompt in their laptop. Okay. So what I will also do, I'll go to now, since I'm working everything in the same folder, same laptop. Okay. So just assume this screen is of another person. So now I want to do my changes. Now for this, what we will do, we will do once again the clone. Okay. Now as a same user, I'm not interested to do. I'm just showing as a different user if you want to do. So now here, I will not clone it as workspace 01. I will create a new workspace called workspace 02. so that you differentiate that. Okay. So now what happens? Inside this folder, there is a new workspace created called workspace 02. Okay. So this is the first one. This is the recent one. So now if I go inside this workspace 02, okay, so now using cd command, I'm going inside. So where am I? I'm exactly inside workspace 02. So now here, what do you see? Those two files which was available on the remote repo. So whatever is there in the remote repo at this time, it has done a clone. Just to cross check, you see you have two lines in it, and same way, let me clear the screen and show you. And here, if I do a git log, you should see 3 commits. I'm sorry for that. Yep. So you should see that. Let's do that again. So here you should see that this is the latest change what you have done. So whenever you do a clone, what happens? At that time, whatever you have in the remote repo, you will get it. Okay, so now what we will do, from the workspace 2, let's do some change and push it. Okay, so here what I will do, I will create a new file called dummy.java. Okay, and let's edit this file. And here, same way, what I'll do, I'll put date as December 28th, 22. Okay, so what should we do now for this? Git add dot. Okay. And then git commit. Here, I'll say third check-in. Okay. And because of this, you should have got a new commit ID. Okay. So you have test.java, ignore the readme. So you have dummy.java. And where is it available? Only on this workspace called 02. Just to cross check, see here, I'm going to workspace 1. Do you see that file? No. Same way. Let's go to remote repository. Do you see that file? It's not available. So unless and until you do not push, you will not be able to share it to others. Got it? Okay. So now let me go back to the workspace 2. So here I will do a git push. So when I do a git push now, where is it going to share? It is going to share to the remote repository. Okay. So you see this location? It's exactly going to remote repository. Okay. And everything is up to date. So now come back to your remote repo and refresh. So you should be able to see the dummy, and corresponding to this, if you want to see the commit ID, you should see the new commit ID. So this way, now I want you to go back for a minute in the distributed version controlling system diagram and look into this. So now pay attention and see the diagram what we have told. So you have the remote repo. Anytime you want, you do the clone, you modify the changes and you push it. Same way, now we created a new workspace by the clone and modified, and then we have pushed. This is where now the changes what is available in the workspace 2 is updated in the remote. But what if the first workspace or the other person who is working, he wants the latest changes what has been pushed? So that's where you don't have to do the clone again. So all you have to do now is pull. So pull will take the latest changes from the remote and update into your local workspace. So come back, and this is where here you see I'm on my workspace 1 and I don't have the latest changes. So here what I should do, I should do a git pull. So if I do a git pull, so it will take that new commit in which you have the dummy.java. So now if you see, the workspace 1 got updated with the latest changes. So this is how you push your changes to the remote, and if you want to update your workspace by taking it from the remote repository, you need to do the git pull. Got it? So push from your repository to remote, and to update your repository you should do a git pull. Okay, clear? So you have to clone, and after that modify the file, git add, git commit, and git push or pull. Okay, so this is the basic workflow. But let's look at it a little deeper. Now this is where it's not going to be as simple as what you are thinking, where you will do the push and you will do the pull. Because sometime, now what happens, we saw the benefit of using version controlling system or a tool like Git is for parallel development. So what if the same file has been modified by you and it is been getting modified by someone else? So now if someone is trying to do a push, what happens before you do the change, someone else has done the change and pushed it into the remote repository, then you will not be able to do push. It will clearly tell first you update your workspace. Okay, so to understand, I'll do it both parallelly. So let's take this dummy file. Now, as of now, what is happening? The remote repo and your workspace 1, workspace 2, all of them are in sync. Because if I do a git pull again from here, it will clearly tell nothing to do. So everything is up to date. Okay. All right. So first what I'll do, watch carefully. I'm going into workspace 1. So here I'll edit the dummy file. Okay. And here what I'll say is we'll put, I'm just printing my name. Hi Adam. Okay. So where is that we have modified? In the workspace 1. So let's do git add, git commit. Okay, so I'll call this as fourth check-in. However, this is from which workspace? Workspace 01. Okay, fine. So you have this commit and this file is available. Now, is it available on the remote repo or on the workspace 2? It's not available. And however, I have not yet pushed. So let it keep it the same way. Now let's come back to this workspace 2. What do you see? This file. So now let's edit this file. And here, what I'll do, I'll say, hi students. Okay. Same file, different line from different workspace. Okay. And let's do a git add and git commit. And once again, from this repo, this is the fourth check-in. So that's where the same comment, but I'll say workspace 02. You see, different contents, and because of that, different reference has been created. So now what happens? Let's say from my workspace 2, I do a git push. So what gets updated in the remote repo? Workspace 2 gets in, right? So now go here and refresh. See, after the third, what did you get? Workspace. So now come here, files. So what do you have? Dummy, and click on dummy. What do you see? Student. Okay, perfect. Now, this is where this person, the workspace 1, he didn't know what has been getting modified, right? So at this place, he thinks, okay, I modified my file, I created a commit, so let me do a git push. See what happens when he does a push. So it clearly says that you are not able to do the push because in the remote there has been some additional changes that is already done. So if you try to push, that will not be accepted because content is kind of different. So what he has to do is do a git pull, so that he has to first update his workspace, and on top of what is existing he should modify and push. So it doesn't mean that he has to again do the change, but he should just do a pull, update the workspace, and then push. So watch this. So what is it saying? It did a git pull, but look at the last line. It's saying there is a conflict. Why? Because it updated the workspace, but what happened to the file dummy.java? The second line which is available in the remote repo is hi students. But what do you have in your workspace? Second line is hi Adam. So which one it should take? So that's where sometimes when you do the pull, if the same line has been modified with different content, Git doesn't know. So we need to resolve that conflict. So how do you resolve that conflict? So now if you open the file, okay, you should see Git clearly shows with arrow marks. So the arrow mark that you see with left side indicates the current content of your file, that is your current destination. Whereas what is this right side? Represents from the source what you have taken. Okay, so that way it differentiates this with the line. So it is saying for every line, what is the difference? So right now there is only one line in which the conflict is there. So it says in the line 2, what you had is hi Adam, but what you have got is hi students. So we have to remove everything and fix. So for now, if I want both of them, then what I'll do, I'll just delete all these lines. Okay, so this is how I want the content. So first we need to update our workspace. So remember, every time full will not work out. Sometimes you might get a conflict which you need to resolve. So now this is like again I'm modifying the file, right? So once again, anytime you modify the file, what you should do? Git add, put into the staging area and create a new commit for that. So we'll say git add dot and git commit. So now we'll call this as fifth check-in. So now what does this dummy file contain? These two. And here, if I do git push, so what will happen? It will try to push the new commit ID which had these two lines to the remote repo. So let's go back here. And now I refresh this file. Do you see? Okay. Same way, if I come here and see the commit ID, look at the flow now. Okay, why Git was not allowing you to push? Because a transaction needs to be in order. Only then you will be able to know everything. So see the order now. First check-in, second check-in, third check-in, then fourth check-in from workspace 1, right? But in meantime, what did you do? You did the fourth check-in in workspace 2. However, look at the order how it has taken. So when you pushed, it aligns everything. Because let's think like a bank. Okay. Now you are working. Okay. So let's assume you took an ATM card. Okay. Your ATM card. You went to ATM. Okay. By the time you are going, someone at your home is doing some online shopping. Okay. So the same time when you are going to ATM and you are trying to log in, someone did the transaction. Okay. What will happen? So let's say 1,000 rupees has been taken out of your account for some shopping. Yeah, it's a huge money. But if you go to your transaction, should it show you what is there at that time without the 1,000 rupees? No, it should also include and show. So that's where if you try to log in at that time, there might be some glitch. Okay. So then when you just log out and log in, you should be exactly seeing that there is 1,000 rupees removed, and on top of that, what is that? You have everything. So this is how, why I keep calling it as a transaction, because it keeps a track properly. Because just you do a push without any tracking, it will be difficult for you to know. But now if you look at the commits, I can clearly tell who modified, what was modified, and how it was taken. Got it? So this is your basic workflow. Okay, just to repeat, what's the basic workflow once again? Git clone, and then git add, git commit, git push, and typically before you do the push, you need to do pull at any time if you get a message that you are out of date or your local workspace is out of date. And the other thing, what using the Git client will be always available only on your local repo. Okay, so that's the first thing. Clear? That's a simple workflow. Okay. Okay.
So if we remove after a pull during the fifth check-in, I mean before the fifth check-in, when you did the pull and it was showing the arrows, right, like left and the right arrows. If we remove all of it and give a new
Push
one,
it will take, because everything is incremental. Already something is there, you have taken everything and you're updating on top of that and you're pushing. So that way there is no conflict. But before that, someone tries to push, then it will give you an error saying that, hey, you're doing some change, but already between that, there is someone else put some metadata. So take that, and then if you want, delete everything and put on top of that. Just like a transaction, I said, right? It should always take the latest. On top of that, you need to modify.
If more number of lines are in the file, only the arrow mode will represent.
For every line where there is a conflict, it will show you. Right now, there was only one line. That's why I simply kept it. Suppose if you have two lines, then the arrow mark will be clearly showing for every line where the conflict is there. Okay.
It doesn't show that line number.
Yeah, it won't show. That's because it depends on the editor. But if you open the file, it will be clearly showing for every line where the conflict is there.
So if both the users are doing the same changes like hi Adam and hi Adam in both the workspaces, and will that be any kind of a conflict it will be showing?
Okay, so it won't show a conflict, but sometimes there will be two reference that it will take, because metadata might be different. Because when we say metadata, metadata is not just with the content. It also takes the username and it also takes the time and other details and then puts together. I'll show you that. Okay, but yeah, that's one of a rare case. No one will be putting that with the same content. Typically, when you do, all it will tell is just do a git pull. No conflict will be there. That's all.
So is it going to be case sensitive by any chance? Because when
It
we
is.
write our codes, it will be having a case sensitive. Like one user will be
It
differently
is.
using.
It is because it tracks each and every line. A capital A and a small a is not same. So that's where it checks the content. So when you generate a metadata, it's going to be different. I'll talk about how it generates the metadata. Okay.
Yeah, actually, here now we are just given 4 commits only. When we are going for the real-time scenario, there will be some hundreds of commits. So if we are giving the command git log means, we'll get all the hundreds of commits. So if we need only
We'll see that.
top 4.
We'll see. Wait.
And one more thing is like, what is the purpose of the staging area like? Because everything that you are going to do in the workspace, you are going to directly load it in the local repository, right?
We'll see. Don't worry. I'll answer all your questions, but not jumping guns. So now you understand what's the concept.
And see, if we are working on the local directory, okay, we are instead of moving the things to remote repository using git push, first we will check whether any changes are been done. So first we will check
Yeah. So
if a git pull,
correct.
then only you go for git push. Right?
Exactly. So that's a good practice. Before you even commit, always do a pull and find out is there a thing, because after you do a commit and then you do a change, it will be difficult. So it's better that you do a pull first, update your workspace, and then do the changes and commit, and then do the push.
Let's say if two developers are working on the same code, and these two developers are writing a code in a two different ways, but the two codes are right actually.
Yeah, it doesn't matter. That's what will happen. See, same file, same line, you will get conflict. But if not, same file, different content, when you try to push, Git will clearly tell you, hey, you're trying to push, but the baseline for that has been changed. So try to do a pull, update your changes. So then when you do a pull, the lines that you don't have, which is available in the remote, will get added. And then your content will be up to date. Then you have to do a
Let's
push.
say if in there like 5 or 6 lines is matched actually, will these two developers think
If
about
there
the
is
push?
something which is not matching, it will give you a conflict. That is what
Then
is the
these two
concept.
developers will
Yeah, it's
talk and
between the developers. Yeah, obviously that's how you need to work, because you will not know. So you need to work with them. See, practically it will not be something where at the same time two files will be modified, but there are some rare scenarios it will happen. But at that time, which is where we need to do what is called as a code review. Okay. Now, yeah. So if you go back to the first three classes that we had kind of last week, so we were talking on the server side of the Git, which is GitLab, and in that I was talking about what is the workflow in the development, right? So in the continuous development, we do a concept called as code review. So that is the time you will be capturing all those things, what is good, what is bad, because we are not going to just blindly allow anyone to push anything to remote repository.
One last question. So, suppose we see like now terabytes of now, data in terms of coding and the application entirely. So cloning that it would take like a lot of
Yeah,
time.
that's the
and space.
disadvantage. I'll come to that.
Yeah.
So before we jump, I think what you actually need to understand, where are those three areas that I was talking? Yeah, I thought. So where are those three areas? Okay, because I just now told you have working directory, you have staging area, and you have repository. Typically, staging area is a virtual area you cannot see. But where is the other two? So in fact, now if you look, where are you seeing the files? You are seeing the files inside this folder, right? So your workspace itself is acting as a working directory. Okay. Then where is the repository? So your repository is a hidden folder. So you see, there is a folder called .git, and this is your local repository. And if you just go inside and see, you will have a lot of subfolders and metadata information. So never ever tamper this, because if you remove this .git folder, then this becomes a normal folder in your laptop, not a Git workspace. Okay, so all your metadata is getting stored into this Git. So this is how your workspace itself is acting as a working directory, and your .git folder inside your workspace is acting as the local repository. And in between, you actually have a staging area, but again, everything happens inside the .git. Okay. Now,
their main is the branch.
don't worry about this. Let's not jump into other topics. I'll come back. So clear so far? Where is working directory? Where is your Git repository? Okay, so this is your local repository. Now, another thing that you need to know is when you're working in Git client, everything is treated as a file. Okay, in Git doesn't care about folders, it cares about files only. Now, there is a life cycle of a file on how it tracks all the file. So usually, if you have a new file which is available only on the working directory, you have not yet added to the staging area and you have not yet committed anything, then those files are called as untracked file. So the moment you put a file into staging area, it will create a snapshot, and that's where it starts tracking. Okay, so that's where directly you will not be putting any file from your working directory to repository. Okay, so if you see a file which is called as untracked, the meaning of that is you have not yet added the metadata of that file into repository, okay, or at least staging area. Okay, so that means these are new files where you have not tracked it. But as soon as a file is already tracked, then the status of the file will be any one of them. Okay, so this is where as soon as you do a clone, what happens? Whatever is available in the remote repository, you are able to see it. So have you done any change at that time? Nothing. So whatever is the file in the remote, you have also seen that. So that way the file are generally called as unmodified. So now when you modify the files in your working directory, the status of the file is shown as modified. So when it says modified, try to understand what it is saying is, I know about a file and I know about the content of the file, and I also know what is that you have modified, which you have added or deleted on top of it. So that's how Git tracks that this file has been modified at this line or what are the contents. Okay, so now after you modify, what do? We put it into staging area. So as soon as you put into the staging area, the snapshot will be created, and that's where the status of the file is called as staged. Okay, now after you put into staging area, what do? You commit. So as soon as you commit, what happens? The content in your working directory is exactly same as your repository. So that's where the status of the file becomes unmodified again. So this is the cycle. Okay, so untracked and tracked, and in the tracked it can be unmodified, modified, or staged. Okay, so now let's try to see that. Now, how do I see about the status? And this is where you have a command called as git status. Okay. All right. So now take any workspace. Okay. So here, if I say git status, what is it saying? Everything is up to date, nothing to create. Which say it means it is unmodified, because how many files are here? 3 files. Okay. Out of that, all the 3 are updated and it is stored. So whatever you have in the remote repository or in your local repository is what you are actually seeing. So there is no change, and these files are being tracked. So now what we will do, let's edit this dummy, or let's say this test.java, and here I'll add a line called as git. Okay, so at this place you have modified. So before even you do a git add, now watch. It was saying no modified or unmodified, right? So now if I say git status, what is it saying? So what is the meaning of modified? So it is a file which has been tracked where it had some different lines in the repository, but what you have put is a different line. So that's how, what is that? It's clearly saying that it is modified. Okay, and look at it, what it is telling. It's telling you have not yet added to the staging area. Okay, so now if I go ahead and say git add dot, on the backside what happens? If you do a git status, what is it saying? It's modified, but it's ready to commit. Okay, getting this? And now if I do a git commit, and what happens? Git status. So once again all the files become unmodified. Why? Whatever the changes that you have has been checked in. So what you see in the repository and what you are seeing in the working directory, both are seen. So that's how it started tracking. Okay, so this is for the existing files which is known to Git. But now let us take a new file. Okay, so at this place, if I create a new file, just watch this. So what we will do, I'll create another file called new.java. I doesn't care about the name here. Okay, so you have a new file. Go ahead and do a git status and see what is it saying. It says untracked, and typically it says it's a new file. So I don't know anything about this file is what it is saying. That means it's a untracked file. So this is where now when you follow the same process, git add dot, what happens? You see, now you see the importance of staging area. Only when it gets into the staging area, it creates a snapshot, and only then it is saying the file is new file. Until then it was saying it's a untracked file, and now it says it's ready to commit. Okay, so now yeah, I can go ahead and add it. Now this is where you don't have to keep on modifying one file at a time and add. I can also take multiple files together. So let's say now I have added this. So in the staging area I have only one file called new.java. Now let's go to dummy. Okay, and here we will just say, I'll just put today a good day. Okay, and now let's look at the status and watch what clearly it says. So what is it saying? Watch it. It's saying there is a new file which is available in the staging area, and there is an existing file which has modified and it is not there in the staging. At this place, if I do commit, what will it take? It will take only the files which is there in staging. Now, as I said, the purpose of staging is you can keep adding. So now if I want both of them, I can go ahead and say once again git add dot and do a git status, and what do you see? Both the files are ready for commit, wherein one file is an existing file and another one is a new file. And you go ahead and do a git commit. Okay, and now git status, everything is unmodified. So now for any reason, let's say new.java, okay, and I just put a line here. Okay, so what it should tell? Git, it is modified. Why? Because now as soon as you have put the file into staging and checked in, so Git has started tracking this file. So that's where the file is no more called as untracked. The file is called as a tracked file, and in that it has been modified. Okay, so clear on this? Yeah, it's very necessary because as you modify, right, you will not be able to know what you have put into the staging, or later we will learn if I want to remove something, how do I do that? Okay, so anyway, so now here if I want to add again,
Before committing that, yeah, changes whatever we have done to the file, which is available in staging area, we can remove that.
yeah, we'll come back. That's the next topic. Okay, so right now clear with this. So now if I go ahead and do a git commit, it says it's not yet staged, so I have to add it and then git commit. All right, and now let's do a push together. So now when I do push, how many commit IDs it is going to push? 6th, 7th, and 8th. All the 3 commit IDs it will be pushing. So come back here to your repository and just refresh. And according to that, you should also see the files. All right, cool. So clear with the life cycle, so that you should be able to differentiate. Now we'll also see a couple of other things. Clear until now? Okay. Now let's move to the next. So what happens? So you have your local workspace, you modify and keep pushing it to the remote repository. Now, especially when you are developing, okay, like a programmer, you need to do some tests before you commit your file. Okay, so that is what I was telling in one of the basic class called as review the code, and you will do a unit test. So typically, if you are doing some unit test of your code, that could be a Java code or a .NET, or let it be some application you're developing or some Terraform or something else, okay, or Ansible, whatever the code you have, there will be some runtime files which will be generated. Runtime files means some additional files to give you some logs information. Okay. Now this is where, like, if you take a code like Java, when you try to do a unit test, before that it will create some object files, okay, or your build files like jar or var or some class files or log files. Now all those things will be stored in your current folder. So what happens now is, when you try to do some test or when you try to run some build or anything similar, all the files will be stored in the working directory. Out of that, remember, newly created files are called as what? Untracked files, exactly correct. But it is not mandatory that all untracked files has to be added to the repository, because if there are some runtime files which is not needed to be stored into the repository, what happens when you do a git add by mistake? So what I'm trying to tell is like this. Let's assume you have a Java file. You try to do a test on that folder. Along with your Java file, it will also create some class files or log files. So now in that folder in your repository, you have 3 files. Even though you have modified one Java file, when you test it, assume you got 3 files. But out of those 3 files, you are not interested to store those 2 files. So, but when you do a git add after your test, what will git consider? Git will take all the 3 and it will add it to the staging area, and by mistake when you now do a git commit, what will happen? Those unnecessary files will also get into the repository because you're unnecessarily tracking it. Now this is where, how do I selectively say, whenever I'm running some commands like git add or git commit, I don't want to consider some files. Okay, so this is where in Git, by default, if you run any of these commands, it will consider all the files in your workspace or working directory. So if you want Git to ignore some kinds of files, then there is a method for that called as git ignore. So what you have to do in your workspace on the working directory, you create a file called as dot git ignore. So dot represents a hidden file. Okay. So in Linux, anything a dot before a file or a folder, it's called as hidden. Like just now we saw for a remote repo, dot indicates hidden folder. So here dot indicates a hidden file. So now, if you put a file name inside this git ignore file, and then when you try to run the git commands, the local workspace, right, the git client will ignore that file. So that's how, when you are doing some changes or when you are developing some file, you need to tell git what files to consider and what files not to consider. So it is not only for developers or programmers, even when you are running some test cases or being a DevOps engineer, you run some code like Terraform and Ansible, right? You will be getting some runtime logs. So if you do not want Git to consider them, then you need to add all those files into this file called as git ignore. Okay. So every repository should also have a file called as git ignore. And you need to understand this is also a file. So you should also check in and store it inside your repository. But why do I say it as hidden? Because a user doesn't have to see this file every time. But the content of this file will be the name of the file which Git should ignore. It can be directly a name or it can be a pattern. Okay, what do I mean by that? Let's understand it now. So let's come back here. Okay, so watch this. At this place, I don't have any changes. Okay, now, like I said, let's assume I opened this new.java. Okay, and I just added some content. Okay, fine. Now, as a developer, I'm trying to do some unit test. Okay, and I ran some commands. Let's not worry about that for now. Now, because of that, it created some file. Okay, so let's say it created a file called new.log. Now, this is not needed to store this file. It is only as an output of what I did some testing. But what happens now when I say git status? It's clearly considering this as a untracked. In fact, git status is also showing this, right? And not only that, anything that git status shows, if I run git add, it will take both of them. So this is where what I can do now. Watch this. In my current folder, I will create a file called as git ignore. And here you can put a file name or a folder name or a pattern. Now I don't want just one logs. I'll just say any file which ends with .log. So the name can be anything, but in this workspace, if I have a file ending with .log, don't even consider that. That is what we are saying. Okay, so now watch what happens. The same git status command, if I now run, it's showing it is still untracked. But what is it showing? Is it showing your new.log or test.log? No, right? But what is it showing as untracked? Is your git ignore. Because like I said, you should also add your git ignore to the remote repository. But is it showing that log file? It's not at all showing. Now, how many other logs file that gets generated? Okay, I'll just put once again as test.log. Okay, so basically now how many log files I have here? 2 files. Still, when I say git status, it doesn't consider. So that's where any file name that you put into git ignore, none of the git commands will be considered. So whether it is git status or git add, it won't even consider. So that's how, when you are actually developing any unnecessary file formats, you should put it into git ignore so that you modify and you add, it will be safely taking only the necessary files, not all the unnecessary runtime files. But however, we need to add this also into the repository. So that's where go ahead and add, okay, and git commit. And let's do a git push. Okay. So in this workspace, now no matter what kind of log files that I generate, it will not be considering. Okay. So now if I say git status, it says nothing is there, even though you have a file which is untracked, but now it is not at all considering as untracked. Why? Because it's completely ignoring the file. So even if I create another log file, something like one.log, it never ever considers. This is how safely you can ignore any of the unnecessary files to be tracked. Okay. Clear? So now you cannot see that ignore file here because it is hidden. So in Linux, if you want to see the hidden files, you should say ls-a. L means long listing. ls-a will show you the hidden file. So now you can see a .git is the hidden folder and .git ignore is the hidden file. Same way, now that is available on your repo. So from now onwards, anyone who does the clone of this, and when they try to do some test, and if there is a log file generated in the local workspace, it will not consider. Okay.
So if we have to modify the dot log file, then
You don't have to modify the log. Like I said, this is just an example. That's just a runtime file, which is as an output of some commands that you have run. That is not needed for you to store. Okay, that is only for your reference to do some activity. That's all.
So let's say no, I don't want to track the file and I kept that in .ignore file. After some time, I thought that I need to track
Yeah,
that
go
file.
back to git
Just
ignore,
delete from
remove
it.
that, and it will check in again and it will start tracking. Okay. Okay, now I just have another 10-15 minutes, so hold your questions. I'll take it up at the end, but let me talk about other topics now. Okay. There are small topics, but if you pay attention, it's going to be very easy. Okay, and this is what we just now learned. Actually, let's get a little deeper into your comments. Okay, so what happens? So every time when you do a git add and git commit, a new commit will be generated. And for every new commit, a new ID will be generated and it is going to be stored. Just like your bank transaction, every time you do transaction, a unique ID will be generated. Okay. Now, when I say commit ID, how is it generated? So it is not like only with the content. So it is actually what we call it as a checksum. Now, if you don't understand what is a checksum, so what Git does, when you add the files into staging area, it will take not the files, but it will take the difference of what was earlier available and what is that you have modified. Okay, so it will take that difference and it will also add information like who is modifying, when was it modified, and it will collectively take that data and it will convert it into a bit value. What is it? A bit value, zeros and ones. Okay, something similar to that. And that is what we call it as a snapshot. Okay, so this is why when you are trying to modify, even though you modify the same file, same line, when it tries to convert that data, metadata, into the checksum or in the binary digits, right? It will not be same. Line content is same, data is same, but the supporting data like the user is not going to be same. So that's how staging area is important, because it generates that snapshot internally, which is nothing but a checksum. So it's not easy to crack, like how you have a transaction ID. Even if you take 1 rupee, there is going to be a new transaction, and at any time you cannot edit, change that. Why? Because if you do it, the whole data of your bank account is missed. The same way, the checksum, what it generates is what? A 64-bit value. Okay, so it cannot just directly be changed by anyone. So that's where it's very safe. So in order to do that, you need to put it into staging area. And every time you put into staging area and commit, a new ID will be created. Okay, just like your bank transaction. And now, when you start working at the commits, you refer them as commit ID. Okay. Now, every commit ID is a 40 long characters. What is it? A commit ID is 40 long characters that you'll have, or 40 characters will be there in every commit ID. Okay. And whenever we talk about commit IDs, you always have the tip of your commits. Okay, so that commit ID, which is the latest commit ID, we refer them as head. What is it? Head commit ID. So in Git, head represents the latest commit ID that you are referring. Okay, so now what happens when someone modifies the code, add and commit? Once again, what will happen? A new commit ID will be there. Now look at the diagram. So the head reference will be moved from that commit ID to the next commit ID. So this is how every time you do a commit, what happens? the head reference will be moved to the latest commit ID. So in simple, head is a reference which points to the latest commit ID. Okay, clear? Now we need to understand this concept as we move forward. But clear now what happens inside your repository? So every commit has a new ID and there is something called as a head reference which points to the latest commit ID. Okay, how do I see? Now let me show you. So come back. Okay, now this is where you should be using git log. Now typically when you say git log, it shows you all the all the commit IDs in your repository. So right now how many commit IDs we have? We have plenty, right? However, out of that, what do you see here? So this is the latest commit ID what we have. Okay, now if I do a check-in and do another commit, what will happen? You will get a new commit and you should see the head reference moved to that. So head always points to the latest commit ID. However, especially when you are working on Git client, it's not easy to see all of them. So that's where what you can actually do, I'm just going to take this command for now and put it here. So when you say git log, by default it shows all the commit IDs. Now what you can also do in the git log, you can say git log and a number. Okay, so a number typically indicates how many commits that you want to see. For example, in my case, they have so many, but I want to see only the last two commit IDs. So that means from the head reference, show me the two commit ID. See this? Okay. Now, same way, a commit ID has certain information. So what and all you have in the commit ID? You have the 40 characters and look at who is the author and the email ID. So this is the one that we had given it in the git config. So this is how when it does a commit and if I'm looking at it, I will know who was the person who modified. And if I want to reach him, what is the email and the date and the time. And this is your commit message. Okay. Now, if I want to see the latest commit ID where you are working, just say -1 and it shows you this is the head reference. This is where we are currently focusing. Or now, if you actually understand it like this, going to a working directory and you are seeing some files, it is because it is showing you what is the metadata stored in the head reference. Because sometime we can also go back to old content. So at that time, if you go, you should be able to see only the content at that level. Just like your bank transaction, when you take a history, if you just go back to some old date and if you see in that transaction, it will exactly tell you what was the total amount at that time for that transaction, right? The same way here, remember, why are you seeing these files? Because the head reference is pointing to this commit ID, and in this commit ID, these are all the files available and corresponding to the content. Okay. Now, if you do not want the complete output, there is also something called as one line, so that it will just show you everything in short format. So now you can see it's not showing you the author, timestamp and the other details. Instead, it is giving the short form of your commit ID, which is the first 8 characters. Okay, and then same way, now if I want only the 3 commit IDs, I can also use like this. Okay, so this is how you are going to see what commit you are currently working. Okay, git log -1. So you can say one line and the commit. Okay, but remember, a head reference is where you are currently working, which is the latest. Okay, clear? Okay. Why did we talk about all these things? Is because the next topic what we have highly depends on this. Okay, so pay attention. Now you understood, right? Head reference means the latest commit ID, and because of the head referring to the latest commit ID, you are seeing the files or seeing the content in the workspace. Okay, clear so far? Okay. Now another topic, okay, which is undoing change. Because so far what we saw, the basic workflow. How do you modify? How do you add and pull or push to your repository? Wherein now, technically, if you understand, what are you pulling or pushing?
Changes. Changes.
So in your bank, what is that you see? Are you seeing your money?
Transaction.
Transaction. So in Git, what is the transaction?
Commit IDs.
Commit ID. So what do you pull and push?
Commit
Commit IDs, not the files. So that's where Git stores everything not as file but as that metadata, which is where that snapshot or staging area helps us to put it. So it's not the file and stores. Okay, it stores them as metadata or checksum. Okay, so remember, pull or push happens only for the commit IDs. But how does it convert? That's what is the work of Git. Now, what is that I'm trying to talk about is undoing a change, because you modified, but that doesn't mean always you will be doing a git add and git commit. So you will have a requirement where you need to undo certain things. Now, in Git, undoing is not so simple as what you have thought, but it's just that we need to understand. So what happens practically? Now, let's say you have cloned, there are some commit IDs available and there is a head reference, and because of that you will be seeing that file in the working directory or files in the working directory. What do you do now? You modify some file, okay, and then you do a git add, and then what happens is, how does git track by saying it is modified? Because you saw that, right? As soon as you put into the staging area, it clearly shows that it is new file, not just modified. It says new file if it's an untracked. Same way, if I add some file, it clearly says that. So what happens is, now assume there is a file, there is one line in it, and that is what is your head reference showing. But now the same file, you added another line. So how does Git know that you have added another line? It's because it creates a temporary reference in the repository. Okay, it doesn't actually create a metadata, it just creates a temporary reference. So what does this temporary reference tells? So there was some content which was referred by head. On top of that, this is what you have done. So that's how, using the help of this temporary reference, it clearly says what is pointing by the head reference and what is that you actually have in your file. Okay, so when does this happen? When you put the file into staging area. Okay, and then when you do a commit, what happens? It takes this temporary reference, creates the snapshot and stores it as a checksum or a commit ID. So that's where this temporary reference becomes the new commit ID and the head reference. Okay, just remember this. So why am I talking about this? Because now, if you want to undo something in Git, it is not just going to a file and undoing. Okay, so now there are different scenarios. One is, have you committed the file? Okay, then how do you undo it? Same way, before even doing a commit, only in the staging area, if you want to undo, you have to modify the file contents. There is already something stored in the staging area as well as this. Even though you have added into the staging area, there is a temporary reference created in the repositories. So you have to remove all of them, because remember, only thing is you are able to see the files in the working directory because the head reference is pointing to some commit ID. So now what is happening? The temporary reference is there. So when you say undo, you need to know how to do undo. So there are two ways. One is if you have committed, how to do undo. Before the commit, how to undo. So that way, now let's focus about before you do the commit. If you want to do some undo, how do you do it? That's when you will be using an option called reset. Okay, so pay attention. So when do you use reset? Before you do the commit. That means you might have the file only in the working directory, or you might have it in the staging area. Now this is where now you modified some file, you added into the staging area. So what happens? The file is actually modified in the working directory, as well as there is a copy of it in the staging area, and because of that there is a temporary reference inside the repository. So all these things are there. Okay, now when you say reset or undoing this, once again there are three modes of undoing which corresponds to each of this area. Okay, so pay attention. So the first mode of undoing is soft mode. Okay, so now in this scenario, if you do a reset in a soft mode, all it will do is it will go to the repository, the head reference will be pointed back to the original head reference. Okay, so that's the only thing it will be doing, because sometimes you just want to refer from one place to another place, you just do a reset soft mode. So what does soft mode mean? Undo only from the repository, whereas the content in the staging area is still there, the content in the working directory is still there. Okay, however, all these things are before you do the commit. Now the second mode what we have is mixed mode. So the same way, when you modify some file and you are put into staging area, there is a temporary reference created. So now if you do git reset in a mixed mode, what will happen? It will undo from the repository as well as it will undo from the staging area. Okay, so what does mixed do? Remove from repository as well as the staging area. However, in your file, it will be still there. Okay, and that's where the third mode, what you're going to have is hard mode. So now, when you do a reset in a hard mode, what and all will happen? It will remove the temporary reference, it will remove from staging area, and it will also remove from working directory. So all the three will happen together. So now, depending on your need, usually soft mode you will not be using. You will be using only mixed or hard mode. Sometimes you have added two files into staging area. I want to remove one file. Then you are not removing the content from the file. You are only removing the content from staging area. So at that time you should use mixed mode. But if I completely want to undo the files and I want to do it from scratch, then you will be using the hard mode. Okay, so in simple, soft mode works only on repository undoing. Mixed mode works on repository and staging area, whereas hard mode works on all the three areas. Okay, so let's just watch this. I'll do one by one. Now this is where, for this, we are going to use a command called git reset, and you can say soft mode or git reset, mixed mode or git reset. Okay. Now ignore soft mode, you will not be using it at any time, so let's focus only on these two. So for this, okay, so now quickly, git status. Is there anything I have modified? No. And where is our head reference pointing to? 612. So remember this. Okay, and now we will work on the other one. Okay, so pay attention. 612. First, pick a file. Which file you want to modify?
Dummy.
Dummy. Okay. Now, what is there in the dummy file? Okay. So now I will add a new line. Okay. So I'll say, what should I put? Adding just line. Okay. You can add multiple files also, it's not a problem. So because of this, now there is a new line added. But remember that commit ID where the head reference was there, 612, that had only this content. So because of this, now it says it has been modified. But however, if I do git add dot, so what happens now? Not new commit ID. It has created a reference. So at this level, what and all has happened? There is a file modified in the working directory. Your staging area also has the content, as well as in the repository there is a temporary reference created. Okay. So now if I do git reset mixed mode, what it should do? It should remove the temporary reference. It should undo from the staging area. Okay. However, it will not remove the content from the file. So see what it has done. So the head reference is internally moved, so you will not be able to see. But what is it saying? Unstaging. So now by mistake, if you have done git out that, you want to remove that, then you use a git reset mixed mode. And still look at the content of this file. Your content is still there. And now say git status. It clearly says the file is what? Modified, but it has not added to staging area. So mixed mode will only remove from staging area, not from the actual file. Okay. Now let me do the same thing again for hard mode. So now I've added it again to the staging area, and now what does it says? So there is a file in the working directory, and in the staging area you have modified, as well as there is a temporary reference created in the repository, right? Now look at what happens when I say git reset hard mode. Okay, so now it will remove from all the three. Watch carefully. Now you will see what's happening. Head reference is moved to 612. That is what I just showed you here, right? Head reference is moved back, and it has removed in staging area as well as from the file. Okay, so now if I say git status, nothing is available. Nothing is there in the staging area, as well as if you look at the dummy.file, it's there. So when you should use hard mode? So whenever you modify it and you totally don't want to get the change, you want to completely discard the change and start from scratch. So then you will be using the hard mode. So typically hard mode completely wipes out your data because you are moving back the content to the head reference. So in the head reference, whatever was pointing is what you will be able to see, which is where at that time in the commit called 612, whatever we didn't had that new line. So that's where when you undo, it goes back to the head reference. So head reference is very important because you are seeing the content because of what is there in the head reference. Getting it? So other than that, so when you want to undo changes, there are three modes. Now what type of undo is this? Before you are committing. Okay, so before you are committing, that is anything that you have in working directory or staging area, if you want to undo, then you should be using reset, and in that we have three modes. Clear? So undoing before the commit. Okay, now this is where staging area again helps, because by mistake you commit, everything will be stored as a commit ID. Okay, now the next thing what you need to actually know is, why do we really need a reset? Because in Git, store a commit ID, you cannot delete it. just like your bank transaction. Even though 1 rupee or $1 you have taken, there will be a transaction ID to track. You cannot change that. Okay. So the same way, commit ID is actually the checksum or the 64-bit data. Okay. So that's where now, by mistake, if you have added something as a commit, you cannot just undo it or delete it. So now let's talk about another scenario where you tested everything. So everything is fine from your side. So you did a commit, and in fact, you also pushed the code. Now, while QA team is doing some testing, they find out there is some bug in it. Okay. And now they want to remove that code. Why? Because if that code is still there, what will happen? Someone else will do the clone. So they will get your code and they will modify the code on top of that. So now when he submits the code and pushes the code, what will happen? The same bug code will be moving there. So that's where whenever we find there is a problem, immediately we should remove that code. But how do you do it? So that's where now let's say if you are undoing something, you are not going to tamper the commit ID. So what you will do? You will go to the file, once again, edit the file, remove those lines, whatever you need, and then put a new git add under new commit ID, right? That is what you do. That's exactly what you can also do using a command or an option called git revert. So what will revert do is, if you tell a commit ID, now understand, before you got the commit ID, there was a head reference. So from that head reference, you modified and created a new commit ID. So whenever you say git revert, what git will do, instead of you manually modifying the file and doing a git add and a commit, git revert will go back to the previous commit ID, take the content and modify the file and store it again as a new commit. So that way you will not be deleting an existing commit ID, you will be adding a new commit ID, but that commit ID will have the content of your previous commit before the head what you have. So that's where, so if this is what you have, when you do revert, what happens? It removes the existing content, it goes and takes the previous content what you had from that commit ID and takes that and adds as a new commit ID. So this is how every commit ID will be tracked. However, when you refer to this head reference, it will clearly tell you what is the content that you are pointing to. Getting it? So remember, in Git, you cannot delete the commit. If you want to undo a commit, you have to use revert. And what will revert do? Create a new commit ID for that reference. Okay. So let me show you that and you will be able to understand. Okay. So quickly, once again, let me come back to this. What's the commit ID you're pointing to? 6112. So at this level, there are some contents. So let's take the same dummy.java where I have 4 lines. So now what I'll do, quickly I'll edit this file and let me add one line. I'm just saying adding a buggy line. Okay. So now I'm not undoing it. I'm going to commit. So git add dot git commit. Okay. Okay. Line. Let me not push. Let's not worry about pushing. So now if I see git log, so this was the file, but now we added. So head reference came here. Now because of this, what is the content of the file? You see this. So now, like I said, I find out that there is a problem with this. Then I want to undo. So at this place, let me just show it again. So now if I want to undo, you should use the command called git revert and you should use the commit ID. So you can use the short form of the commit ID, which is the first 8 characters. Okay. So when you say git revert commit ID, it will undo. But for undoing, what it will do, it will go what was there before that commit ID, that is 612. So it will take the content and store it again as a new commit ID. So watch this. So it's editing the file, because anytime you do a commit, you need to give a message. So revert is internally doing a git commit, and for that it is asking for the message. So all you have to do is just go ahead and save the file. Now in a VI editor, you will be saying :WQ. So I'm just saving it with the commit message. And now if you look at first, what is the content of this file? You see, it got reverted. However, if you look at the git log, what do you see? So this was the buggy line we added, but now where is the head reference? Head reference is here, because whenever you undo a commit, it will create a new commit for that. Okay, so that's how in Git every transaction will be managed. Just like in your bank, you remove 100 rupees, there's a transaction. Now you add back that 100 rupees, your total money will be the same, but however, you will have a new transaction. The same, you will use git revert whenever you want to undo some changes what someone has already committed or submitted.
So we can do it from the remote repository as well.
Anywhere you can do. No, revert. See, these are the things which doesn't happen in remote, because remote is mainly for managing, as well as it is also for doing the authentications from the user. So go back to our other 3 days that we had last week, right? The initial workshop we did. So we saw what and all management you do. So usually server is needed for managing those. So this is where, as a user level, what to choose, what to change. So these things cannot be done on the server.
Before even pushing the changes from the local repo to the remote repo, we have to do the revert.
It's not mandatory. So
Like
here, see, let's assume you push the code and I found out there is a problem. Then I should do a git clone, create a new workspace. Inside that, I should do revert, create a new ID, and now I can push that once again, so that when you go on top of this buggy code, you will have a new commit ID which has reverted. And then we will ask everyone, please do a git pull. So now if the users do the git pull, they will update their workspace, which will not show the problematic code. It will show the code which doesn't have that. Okay, so every time you have to do this from your client. So this is where client is necessary. Okay,
Even without cloning, we can do whatever.
no, because going back to the basics, how do you get anything that is available in the repo? You have to first do the clone. So right now I'm not doing it because I already have the workspace. But if you do not have anything, to get started, the basic workflow is you need to do the clone, then you will get your workspace. So go inside and then modify, do changes, whatever you want, revert, and all those things should be done.
So in order to modify, for example, if I need to revert some changes, why can't I pull the data from the
Exactly.
remote and
See,
that
when do you do pull? If you have a workspace, then do the pull, it will take later. If not, is where I'm trying to tell. So I'm just giving you a new laptop and I'm telling you, hey, you know what, a user has done some change, it's a problematic, can you please undo it? So then to start, you will try to do a git clone and then get the files. So this is where command, what you're going to do is git revert. Okay. Now again, let me just take another 2 minutes and I'll open for questions, because undoing has one more. So what we have seen now is revert. However, in Git, there is one more concept which you so far haven't actually seen. So go back to the first class. What did I say checkout mean? What did checkout mean? Checkout means
Pulling the data from the remote repository.
you are seeing the data from the remote repository. That is what we call it as checkout. But so far, we haven't used that word called checkout at all. That is because by default, when you are trying to take, there is a content which is already visible to you and you are so far working. However, Now checkout means if I don't tell anything, I'm already pointing to the latest content, because when I do a clone, what happens inside your working directory, the head reference is pointing to the latest code. However, so now for any reason, if I want to see some older data, see, seeing the commit IDs is not the point what I'm saying. What if I want to go back to some commit ID and see what was the content in the file? That's where you will be using the checkout. So you can basically traverse between older content. An example, you did some change, you committed, you pushed, you went home. Someone, let's say, found out that there is a problem in your code and they reverted it. And for that, a new commit ID is given. Tomorrow you come back. Now you are telling that, hey, my code is not there. And for some reason, you are very guaranteedly assuring that the problem is not from my code, but I want to test it again to confirm. Now, where is that content? Everything is gone. But in Git, every ID is tracked. So that is where using the checkout, I can easily go back to any old commit ID. So what happens when you say checkout? Your head reference can be taken from one commit ID and it can be applied to another commit ID. For example, if I now clone my workspace, head will be pointing to latest, and what contents of the file I will see? Latest. If I now want, I can do a checkout and go back to a older commit ID. Now the head reference will be pointing to that. And because of that, you will see the content of the file, what is available at that level. So that's how checkout in Git means seeing a particular content which is already available. If not, you don't have to do the checkout, because anytime you go inside your workspace, by default, you will always be pointing to the head reference, which is the latest commit ID. What do you mean by that? Now this is where now I'll show you. So you have to say git checkout and the commit ID. Okay, so watch this, it's interesting. Now, where is that we are pointing? We are pointing to this place, and at this place, what is the content of the file? Okay, now let me do a git checkout and let's go to this commit ID. I want to see the content. So because of that, now watch what happens. Okay, head reference is moved from 6122 to, sorry, not 612, the latest one to 320, whatever is there. Now because of that, if I open my dummy file, what happens? You see, you got the line back. The same thing was not available some time back because you were pointing to the latest commit ID. Okay. Now, just to show you as an example, if I say git, let me go to the very first commit ID. Okay, see, same workspace. If I say git checkout and the old commit ID, okay, now it is not just the file, your entire working directory refers to that location. So at that time, what was the content of your working directory? You see, you just had test data. You didn't have your new Java, dummy Java, all those things were not there. So that is how checkout in Git means pointing to a particular commit ID, and that is what you will be seeing in the working directory. So from the repository, you are taking the content of a particular commit ID and you are seeing. So that's what in the first day I was telling you in simple. Checkout means seeing the content from a repository. So now if you are clear, what is checkout in Git? Seeing a particular content from a commit ID. Okay. And now when I say git log, see this. So how many git logs it is showing? It's showing only 2. This is because when the head reference is moved, git log will always show from where you are to below that. So now if you want to go back to the old one, then, or let's say I want to go back to the latest commit ID, then just say git checkout and you don't have to tell anything. Or which is where there is something else called as branch, which I'll talk about tomorrow. So if you just give the branch name, now where are you? You're back to the latest commit ID, and you can see all the files, and this doesn't have your buggy line. That's how. What does checkout do? Helps you to traverse the content. So you're not modifying anything, you're just able to see.
See the contents.
However, you can go back and see the content. But what if you want to modify now? You will not modify here. Take the content and modify on top of the latest commit ID. Like for example, think again like a bank. You had 100 rupees today, okay? And I removed 100 rupees from your account. So now how much you have? Zero. Okay. Now using the transaction, I can go back to yesterday's reference. So yesterday's reference will say 100 rupees. Now, if I add 100 rupees to your account, how much will be there in your account? 100 only. Why? Latest is 0 plus 100. Just because I'm pointing to my old transaction, and now if I say add 100 rupees, it should not say, oh, at this reference 100 is there, let me add. Logically it won't work, right? Same thing is here. So you have moved your head reference using checkout, but when you try to do a modification now, when your head reference is pointing to an old commit ID, what will happen? It will not do the check-in there, because if you do a check-in in between, the transaction history is messed up. Just like your bank, what exactly it does? It goes ahead and it only adds a new commit ID. So even though you have a change which you want to do from an old commit ID, for which you have moved to an old commit ID using checkout command, and now when you do check-in, what it will do? It will always create a new commit ID which will be on top of the latest commit ID. So that's where head reference will be moved from one commit ID to old commit ID using your checkout command. Okay, so clear so far? So this is where when you undo the change, before you commit, if you want to undo the change, use git reset. After committing, if you want to undo, use revert. But you are not interested in actually changing the file's content, but just to see the old content, then use git checkout. Okay. So with this, let me stop it for today.